All right, good morning. This is Ron from OnPoynt, and today we are going to build out our 220 millimeter FPV racing drone. So let's pull out some of the items that are in the kit. We'll lay them all out for you. I've opened this kit once, so it may have a couple of things out of a package, but in general you'll see what it all is. And we'll explain these things as we go through, so you get an idea of what they are and kind of what they do, what their function is. So propellers, usually green and black. Here's our flight controller. We have 4 motors. You notice red caps and black caps. We'll talk about those as we go along. Here's our transmitter for the video camera. Here is the camera. Another motor. This is the kit with the frame and some of the other electronics pieces. That's a nut wrench to tighten down the propellers. That is our transmitter antenna. And that is about it. So we'll get to the put the frame together first and talk to you to the different pieces and parts, kind of what they do to explain how the drone works. All right, so here's the kit with the frame in it. Just going to open it up. Take out our pieces and parts. So these are the pieces to the frame. We'll unwrap those here in a second. This is a power wire and a cap, connector cap. We'll put those on. Inside here, there's the Velcro strap that holds the battery in place. We'll save that for later. These are little cushions that go on the bottom of the arms that keep it off the ground. We'll install those later as well. A few zip ties in case we need them. And then these are the mounting pieces we need to build the frame out. Now we'll use these here in a little bit, but we'll save those for later. The pieces we need to start with are these right here. So those are little standoffs that we use. That's the center piece there. And then there's the standoff that keep the power distribution board off the bottom of the frame. And those are the pieces we'll be using first. And then these are the screws. Now, screws are different lengths, so you can see. We use them for different areas, so we'll go through those as well. Here is the frame, all wrapped up in cellophane. So we'll get that apart. Try not to damage any of the carbon fiber as we do it. Alright, so I hope you can see all of these. So these are the arms. We'll mount to the base of the frame. That's a center plate that supports those 4 arms. These 3 pieces here are up for the front of the aircraft. We'll use this one to mount the camera, and those 2 are support pieces for the go on the side. We'll install those a little later. The upper plate and the main lower plate. And we're going to start with the main lower plate today. So, alright, so let's start to assemble. So the first thing we do is take the 4 arms and lay them just like that. Make sure the holes are going to line with the holes below it. Now the advantage, some frames are solid all one piece carbon fiber and some are pieces like this. There's advantages and disadvantages of both. With these, if something breaks in the frame, you only have to replace one piece of it, whereas when it's an entire piece, if the frame breaks, you have to replace the entire frame. So different racers have different opinions about that. So we're going to take the long screws and push them through. I'm going to start with the 4 middle holes. And get them all lined up. Takes a little finagling, a little moving things around. You got to line up just right. Those to go in. And these are the longer screws, in case you were wondering. And there we go. That's the first part. Now we take this small X-shaped piece and it's going to go right over there. And once you've got that on there, you're going to take the whole thing and you're going to flip it upside down again so you can tighten that through. There we go. So it just takes a Allen screw to start to screw that in. We tighten each screw in a little bit to get it all started. Then we can kind of lay it down and put a little more stability into it. Okay. Alright. And that's the first part. Now we're going to use these other standoffs and they're going to mount on there. Now you notice that they're slightly, one end slightly taller than the other, so the power distribution board is actually going to mount to that. So they only go on a specific way, so you got to pay attention when you're putting these in there to make sure you're getting them the correct direction. And they are going to mount like this. Put the screws in from the bottom. We'll just do one arm at a time. And then your power distribution board, let's open this up real quick. Just show you the alignment. So these holes here on the ends are going to align with these four mounts right there. So if you're not sure, you can just make sure, set that on there, make sure that those elevated points are going to go through these holes here on the back. So we're going to put these on just one at a time. Nothing earth-shattering about this. Just going to line that up. Get it through there. Set one on top. Tighten it down. And we just slide that over, make sure it's lined up so that the next screw can hit the mark. And then another long screw goes into the bottom. And threads in nice and tight. All right. And there we go. So that's what the assembled frame lower plate is going to look like. Alright, from here we'll go on to the next step. Alright, next we are going to pull the motors out and talk through them and get ready to mount them. So if you notice, two of the motors have black cap screws on them and 2 have red. There's the 2 black, and here are the 2 red. So if you'll notice on these, there are spin indication markers on these motors. You notice this motor spins clockwise, and the red cap motors spin counterclockwise. They go on the arms in a specific order, so as we do that, I'll point out what that is. So let's get all 4 motors out and get them ready to go. Motors come with screws to mount them in 2 different lengths, and with a small Allen wrench we'll use to tighten them. So here's the frame. So these cutouts in the front, this is the front of the aircraft here, all right? The motor on the front right is a counterclockwise motor. The same motor, counterclockwise, will be opposite it. And that's how these work. So the way these spin, so that they don't spin in circles, is that these 2 motors will spin counterclockwise, these will spin clockwise, and offset each other. That way the aircraft just doesn't spin. So it's that counter-rotating force and rotating force that keep it stable and pointed help keep it stable and point in one direction. And you overcome that equal opposite reaction of the spinning motors. All right? So we're going to start by just mounting motor number 1. I'll just point out an added feature on these aircraft. So these are small little motor mounts or guards. So you can put them on a couple different ways. You can put them on the top where the motor sits inside that to protect the motor, or you can put it, as I like to do, on the bottom where it actually creates a small stand for the aircraft to sit on. I like the way that mounts, but you can do it either way. The other piece that comes with these that'll mount there are LEDs. And if you notice, you have 2 packages of them. One has a red dot and one has a green dot. So these are red LED lights, these are green LED lights. So the preferred method of doing this is the red goes to the back, the green goes to the front. So just think of red as the tail lights. All right? Makes it a little easier to maintain orientation on the aircraft. So since the first motor we're going to put in is the front right, I need a green LED. Now we have to solder wires of these, but we're going to do that just a little bit later. So right now we're just going to take the LED, we're going to pull it out. Keep in mind that solder goes on these points here, so you want that to be at the open end so you can access it. All right? So when you line that all up, the screws are going to go through these holes, through the frame, and into the bottom of the motor. All right. Yeah. This takes a little bit of doing. And again, like I said, these screws are slightly different lengths, so you need the longer ones for this. If you're going to put this together without these green plastic guards on there, you could probably use the smaller ones. Now, I found one of the best ways to do this is just push the screw all the way through and try to line it up on one of the holes and then just start to tighten it in. All right? Again, these aren't very long screws. They don't stick out of the frame very far. All right, and don't tighten it down too hard because you're going to have to probably rotate this a little bit to make sure you get good alignment with the other screws, or you may have to rotate the motor a little bit. So the motor's going to rotate just like that. So these wires are going to come off the front of the motor, off the front onto the arms. All right, so now we're just going to try to line all that up, get the next one lined up and in. You may have to slide the motor a little bit on the arm to get everything to line up. That's okay. That's why you don't over tighten that first screw. Another long one. Like I said, it can take a little bit of maneuvering to try to get these holes to line up. Don't be surprised if it takes you a little bit of moving, sliding things around a little bit to get everything to line up. So I think I got this bottom left one to line up, so we're going to try that one next. Alright, there you go. They don't bite very far. Alright, so that's the first motor on there. Alright, so here we go with the four motors in place. Red and red, black and black. Alright, now you got them all in. You can tighten them up. Don't over tighten these because the metal's not overly strong on those motors and you run the risk of stripping out that screw, stripping out that motor. Then you'd have to either try to get a longer screw or you'd have to replace the motor. So you want them tight, but you don't need to wrench them down. Don't put it in there like that and really wrench it down because you'll definitely run the risk of stripping out that motor thread. Just get all four of them good and snug on each motor and you will be ready to go. And there we go. Alright, now on to the next step. One thing I did want to point out is when you're done you will have some extra screws left over. The motors come with a couple of different lengths. Also these plastic standoffs come with screws as well. Hang on to them. You don't want to get rid of those. You never know when you're going to need them. Each motor comes with its own little Allen wrench. You may want to hang on to it as well because if you're doing some work in the field or you're out on a site, you may want to have one and drop it in the grass. You'll probably never find it again. So good to hang on to all that stuff. Alright, the next step we're going to do is we're going to connect the electronic speed controllers to the motors. So let's take a look at one of these. So the electronic speed controllers, their specific role and function with the aircraft is that they control the speed of each motor. Okay. Now if you look here, you've got three little pads here. All right. So we're going to take the wires to the motor and solder to those three pads. It doesn't matter what order you put them in. All right. Because in the software, if the motor's spinning the wrong direction, we can go in the software and we'll reverse that, and that's what we'll do. All right. So those electronics, these wires from the motors are going to solder onto those three pads there, and then these two wires are going to solder onto the power distribution board when we get to that point. So you notice we have positive points and negative points. These large ones are 12 volts. When you get in here, you can see that here you've got a 5 volt positive and ground. Now, several things run off of 5 volts, so that's why it has a 5 volt pad on there. So the flight controller runs off 5 volts, the camera runs off 5 volts, as do the LEDs. If you connect the LED wires up to 12 volts, they will overheat. Alright? So that's what those are all for. So the first thing we're going to do is we're going to connect the ESCs up to the motors and get those all ready. Alright? So to do that, the first thing we're going to do is we're going to tin and put a little solder on each of those pads. Alright? So I'm going to zoom in a bit. Make sure we get good good video of what this looks like. All right, so we're just going to tin those up. And tinning up, if you haven't done any soldering before, it's very easy. So you just take your soldering iron, you take your solder and include it in your kits. And what you're going to do is touch the soldering iron to the top of that pad, touch a little solder to it, and it creates a little bead of solder right on that pad. So I'm going to bring this up, make sure you get a kind of a good look at what that looks like. We're going to do all 4 of them. And we do that with all the wires as well, and that is to make it easier for the soldering to happen. All right. Now your ESCs may have wires connected to this. All right. If they do, then you're just going to be soldering the wires to the leads on the ESC. But different manufacturers, different availability of suppliers can dictate which particular ESCs come with the kits. So these particular ones did not have wires on there, so we're going to put solder onto there, and we're going to solder those right on the motor wires right onto there. All right, simple, easy process. Put this guy here in the center again. So what you're doing is you're heating up that little plate on the ESC, and you're touching some solder to the plate, and the solder just adheres to that plate. Those are really small little pads, so it's a little delicate. But like I said, some kits are going to come with wires already attached to them, and some are not. All right. So now we bring the aircraft over. Yep. Set that up, and we're going to solder the wires to here. So it's a little easier to do that, setting it off to the side. And as I said, it doesn't really matter. Now you can see these wires. I'll bring this up so you can see it. They're already pre-tinned. So there's already some solder on those wires right there. All right? Should make it a little bit easier. But these are small, tight little solder joints. And be a little tricky. You may have to get a classmate to help you. All right, there's one. Actually, we're going to desolder that for a second. I'm going to put a little bit of heat shrink on here. Don't know that I necessarily need it, but certainly won't hurt. So we'll take a little of this heat shrink tubing, cut little pieces off, and then we're going to slide them over the wires. And then once we have these solder joints on there, we will use our little heat gun to shrink them on. And as I said, it doesn't matter what particular order you do these in, just that the solder joints are good and solid joints. Alright, so I set my little utility knife there to hold the weight. Just spin these up close to it. And there's one. There's two. And there's three. Those three are on there. Good solid joints. We'll slide the heat shrink tubing up over them. You might not need to do this, but this really doesn't hurt anything. So I have a small heat gun to use to shrink this. You can also use your soldering iron, though my engineer Mike doesn't like that I do this sometimes, but it will work to shrink it down as well. Just got to be a little careful with it. You don't want to shrink the wires. It doesn't look as pretty, but I'm more about function and it works just fine from that standpoint. So there you go. So there's one of them. All right. Now when we put these on and mount them on the arms, they're going to mount about like that. If you notice, you got some extra wire here. So what we'll end up doing, maybe we'll do something like this and spin these around this way. Probably not be enough room there. So what we'll end up doing is something along like that. What you don't want to do is have it mounted like that to where those wires are hitting the motor, because the motor eventually will burn through that insulation and do that. So what we'll do is we'll mount them like that. We'll use some electrical tape to hold that in place. But first we're going to do all the soldering, and we'll get that all done first. Okay. This is pretty simple and straightforward. We're going to do the same thing we did earlier with the ESC pads, but if those were a little too small for you to see, kind of get an idea of what we're going to do. So it's just a matter of putting the soldering iron onto the pad. Takes a little bit for it to heat up. Some soldering irons are a little more powerful than others. The one we have is pretty good, but as you can see, it's going to take just a little bit longer. So then the solder starts to melt. And as that pad heats up, it'll just flow across that pad. There we go. All right. Make sure I got that where you can see it. Now if the pad gets hot enough, that solder should flow across it. If you touch the solder right to the tip of the soldering iron, it certainly will melt. But what we want it to do is we want it to melt onto this pad here. And to do that, that pad has to get a little bit warmer. Yep. You can kind of see it flowed a little bit there. That's kind of what we're looking for, is that it starts to flow across that. Now, it is possible to overheat these boards, especially the flight controller, so you got to be a little bit careful with that. You want a good healthy amount of solder on there because it'll make it easier when you start connecting these ESC wires. And as we mentioned, let me spin this around, make it a little easier. The electronic speed controllers get signals from the flight controller telling each motor how fast to turn. And that's important because the way these drones fly is, to fly forward, the two motors in the back will speed up. So when you move your flight control remote control stick to make the aircraft fly forward, the two motors in the back speed up. And when they speed up, it just tilts the aircraft, right? And that tilt is all it takes to get it moving forward, right? So for it to move backwards, the two motors in front speed up. For it to move to the left, the two motors on the right speed up, and vice versa. For the aircraft to rotate and use that yaw axis, then two motors on opposite arms will speed up. And the equal and opposite reaction of that is what will cause the aircraft to pivot or yaw. So, alright, so let's get this where we can see it. So now we've got these four connectors right here. Now, we're going to connect several wires that need 5 volts. What we're probably going to do is connect one wire to the 5 volt and then splice it so it goes into the other devices. But we've got to tin all these points up as well. And they're a little smaller. Now you got to be careful when doing points that are very small like this. Now these aren't too bad, they're not that far, they're far enough apart. But you get into other devices, especially like the flight controller, where the points are very close together, and you have to be very careful soldering those that you don't bridge across. So if you bridged across the positive and negative, what would happen is you would have a direct short. So we're going to test a couple of things right now with our multimeter. There we go. Hitting the wrong connector. So we have 0. We have a direct short. Okay. So when we put these on these points, positive to negative, we should not have anything. Okay, nothing. But we go positive to positive, it should show a direct short, and it does. All right. So what that tells us is that I have good insulation. I don't have a short across the positive and negative on the power distribution board. Okay, that's important. You want to test that early and test it often, just to make sure that you don't have any wires bridging or shorting. All right, so that is it for that. So the next thing we're going to do is we're going to strip out these wires and we're going to solder them onto these points. We're going to use these points right here for positive and negative. So as you'd expect, it's red for positive and black for negative. Again, these are a little bit long, so I'm going to cut these not quite in half, but close to that. I want to get them about the same length, and then we'll strip them back. The batteries have leads on them. Now this is not the exact battery you would use. You could use a smaller one than this, but that's a typical length of a lead for a battery. So the length of these wires here should be adequate, because the battery is going to mount on top and connect that way. So this should work out just fine. So we're just stripping the wires. Don't need to strip very much. And we're going to tin these wires as well. All right. Now you can see that that's not very much on there, but when we connect it to the connector there, we're going to want about that much. All right. Not a whole lot. You get too much wire in there, they get a little bit hard to solder. All right. So first thing we're going to do is we're going to tin these wires. Okay, so I got my wife to volunteer one of her hair scrunchies. So rubber band or something like that on a pair of pliers makes a really good set of second hands. If you've got a classmate, may not need that. But you want to thin these wires out the best you can. And in this case, we're going to tin both ends. Because we'll be soldering it both to the power distribution board and to the connector. Now, this connector is by far the harder of the two. You can see on here, it's also got a marked what the polarities are, positive and negative. So make sure you observe that with the black and the red wire. All right. So our negative is on the top, so that's going to be the black wire first. So we're going to tin this one up. These are actually a little bit easier to tin, but they take a little bit longer. You've got to heat that lower point there. And that is the negative side, so okay. You want to make sure that's got a really good solder joint. That's a little bit weak, so I'm going to heat it up a little bit, add a little more solder to it. That looks pretty good. You don't want to overhit this either or press too hard, because this is just plastic, and if you heat that prong too much, it'll actually bend in there, and then you can't plug a battery into it. All right. So now same thing with the positive side. And again, we're going to put a little more solder in there, make sure we have a good joint. Go. Alright, those look pretty good. It's kind of what they should look like. Soldering is not that difficult, but it can take a little bit of practice. These actually have an insulator, so we'll just slide the insulator on and it should just click in place. And there it is, and that's what it'll look like. Alright, so now we're just going to solder these to the power distribution blade. And that's a pretty good one. Don't be afraid to pull on these and make sure they're going to hold. Don't pull too hard, because you'll pull that pad right off the power distribution board. All right. So there we go. All right. It gets a little warm. Let it cool down a little bit, and we'll get ready to start the rest of the soldering. All right. So just to clean this up a little bit, we're going to take the ESCs. And we're going to use a little electrical tape, and we're just going to tape them down. Now I'm using some yellow electric tape. Your kits probably came with black. It doesn't really matter the color. It's really just about securing those wires so they don't flop around and making the build look pretty clean. So again, keeping those wires from rubbing against the motors. These motors are what they call outrunners, meaning that the outside of the motor spins. Some motors are not. They'll have a shaft that comes up through, but these are outrunners. All right. So we're just going to tape each one of them just to hold those pieces down. So those wires with the connectors are going to eventually plug into the flight controller. These wires, once we clip them back a little bit, they are going to solder to the power distribution board. So just makes it a little bit easier to manage all the wires if we can spend a little time up front kind of taping them down just to get them so they'll stay out of our way. All right, and there we go. So we're going to pull these wires out of the way, keep them out of our hair while we do this. And then these are the wires that we're going to connect to the power distribution board. But first, we're going to mount the power distribution board to the frame. So let's do that. Alright, so the power distribution board is going to mount. So that's the front of the aircraft, this is the back, and we're going to mount it just like that. So in this little bag here, you've got some nylon standoffs, and we are going to use those to mount this board. And you got a package with some additional ones that you're going to use as we mount the other components. It's just small little nylon standoffs. And the way this works is we just line up the hole and thread it in. Now, I'm going to put 2 on here for now, really just to kind of hold it in place. The problem with the nylon is that if you touch that with a soldering iron, it will melt. So you got to be careful doing that. You may also have some screws that came with it. If you want to use one of those to hold them in place while you do this, that's okay. You just know that you have to take them out and change them for the nylon standoffs when you finish the build. So we're just going to put one of those in just for now, just to hold it in place. Take the nylon out of there so we don't melt it. And we're going to go about soldering the ESC wires. As I mentioned before, on the board you've got positive and negative points. So red wire to positive, black wire to negative. These are also tinned. We don't have to do anything else. So you have a couple options here. You can keep them at that length and solder them on there. You just have wires a little bit extra long, or you can cut them down and tin the wires and solder them to there. It's really up to you. We're going to leave these as the original length. That way you can build and rebuild this if you choose to. All right. So that's mounted there. It's just a matter of tighten that up a bit. Hold it in place. So it's just positive to positive. Okay, you want to have a good solder joint. You want to be careful you don't bridge across the positive and negative. Now we are going to, before we put power to this, we're going to check several times and make sure we don't have a short. It does not matter which of these positive and negative points you connect these to. It only matters that you have positive to positive and negative to negative, because these get powered simultaneously, and the amount of speed that each motor spins at, the rate that it spins at, is the function of the flight controller. It sets each one at how fast it spins. All right, and that's done through these wires, these signal wires. All right, so we'll leave that like that. Now you've got some components on here. You want to be careful that you do not put the soldering iron in contact with all these board components, because you can overheat them and burn them out. And that's all there is to that. Now these wires are a little bit, we may use some tape and tape those back down. We've also got to solder wires onto the leads LEDs. Okay, so we'll run those wires underneath here and connect to those. But those take 5 volts. Do not hook them up to 12. They'll overheat and they will start to melt. So there's that piece of it. Okay, next we're going to solder the LED wires on the bottom of the aircraft. Now, these are the wires that come with the LEDs. These are significantly longer than is necessary, even for 2. But we're going to take these and we're going to cut them long enough to reach into there. But we need a little bit of extra, because we're going to solder onto the 5-volt pin here wires that will essentially be a little distribution network harness for powering the camera, as well as the the flight controller rather. All right, so just like we did with the all the other solder pads, we are going to put we're going to tin these pads up. And it's the exact same process that we've done in the past. Just a matter of heating the pad up. These pads are pretty close together, so making sure that you don't bridge those points is important. So we're just going to solder all of them up the exact same way. So LED is actually an acronym, some folks don't know, and it stands for light emitting diode. They're DC, use direct current. You have a positive and negative point on there, and electricity flows one way through it. So those are all tinned. Now we're going to take our wire connectors here, split them apart just a bit, make it a little bit easier. These are solid wires. I believe they are tinned as well. And again, positive and negative, so your red wires to your positive, black wire to the negative. Alright, so I took this wire, ran it underneath here, up through the hole here. It's going to connect up in here. So while we're doing that, I am going to take, now that we've got this coming through here, we're going to tape this down, and while we're doing it, we're going to tape these wires so that they're a little better in place as well. So just a little electrical tape. Let's hold it. And that just kind of holds and keeps the wires out of the way while we're doing it, and keeps that wire from flying around underneath there. Alright, so we'll do the same with the other ones. Alright, so I rerouted these LED wires. I ran them underneath and down through underneath the power distribution board. As you can kind of see, we came through there. Not necessary, but I like to keep the aircraft builds as clean as possible. So I'm going to run it through there, and then we'll work on putting together a small little wire harness that'll connect to the 5 volts, so that we don't have quite as many wires trying to connect to that. So, all right. Okay, so I've got the LED wires all soldered up, taped down, run up through the bottom, and they all come up through here. So we're going to create a little wire harness and connect up to the 5 volt power and ground right there. So just a matter of stripping some of these back and splicing them together, doing a little solder, a little heat shrink, and that we will have fewer wires connecting up to that 5 volt bus that we're trying to get to. So we're going to clip these two off so they're all about the same length, and we'll use one of these as the 5 volt connector wire. Alright. So we'll just strip the wires back, Just going to strip them back a little bit more because we're going to wrap these. So we need them to be a little bit longer, and may have to strip them back a little farther than that actually, because we've got several wires to connect together. So we're going to connect them together and solder them. So between the two functions, we'll have a good secure little area. Same here, we're just going to strip these back and solder them, or strip them back rather, so that we can solder them. These are fairly thin wires. So I'm using my fingernails to kind of split those. If you're having a little trouble with that, you can just run a little razor knife down between them to split them. Just be careful that you don't splice into the wire. Once these wires get kind of short, it gets a little bit less forgiving to wind them together. Alright, so here we go. These are not solid wires, so it's best to give them a little bit of a twist to kind of keep them from fraying. They get a little harder to manage if they're all frayed. Make these two a little bit longer. We can always cut them back if we need to, and have another piece of wire if I run into a problem as well. So what we're going to try to do initially here, see how this goes, is wind all the black wires together. It doesn't seem like it's working all that well. So what we may end up doing is winding together the best we can, and certainly we'll solder them as well. We make this one a little bit longer. Maybe that make it a little bit easier to spin together. There's that one. And then this one will go on there as well, and that will be, and we'll solder all of that. I'm going to cut a piece of heat shrink Can get a little hairy trying to keep all these together. All right. And that's that. So now we'll take our lead wire here, drape it around, touch it with solder one more time. And that's it. Alright. Now we do the same with the positive wires. Again, we may need to make some of these a little bit longer to make them a little easier to get together. Now, that said, the LED wires are not necessary for flying the aircraft. You do not need to have them on there. The aircraft will still function and fly without them. Also, you can add other LEDs if you wish to make them light up different colors. A lot of different function things you can do when you get into a little bit more advanced setup. But they are not required to actually just fly and operate the aircraft. But they look cool, and that's why you got to have them. So, I'm going to do that. Pull that apart. Give myself a little. There's a little sleeve of. Put that over. So let's solder this. A little that. Then we're going to slide the heat shrink over to make sure we insulate these. Now we're going to double heat shrink these. I'm going to do this one right here now, and then we're going to put another one. Alright. Now those look pretty good. You can see a little bit of the wire there, but we should be okay. If they weren't, what we'd just do is we'd split these wires here and run another piece of heat shrink down there and run over the top of both of them if we need to. So now we're going to take these two wires, we're going to tin them up, and we're going to connect them to the 5-volt pads. These are a little long, so I'm probably going to clip them back. But they're going to go right under there, onto power and ground right there. All right. Now keep in mind, we have got to also connect the camera voltage off of there, and the flight controller voltage comes off of there as well. So you got 3 wires going to go onto that little positive lead there. Okay, probably was a little hard to see, but essentially what we've done is soldered those right across there. And you can see good clean solder joints, no bridging, the wires are tight. So our LEDs are going to be powered through there. We'll also connect a couple of wires there for the other components, but we're well on our way. Alright, so now that that's done, the next thing we're going to do is we're going to get our flight controller ready to mount. Now it comes in this bag with all of these wonderful wires and cases and all kinds of things. So we're going to pull that all out, dump it all out. Now the case you don't need and we're not going to use. When you stack these, you're not going to want to use that case. And we have several of these pins. All right? So there are 2 sets that we have an option to mount onto our F3 flight controller. So one set like this. They slide in just like that, and then you mount them and solder them on the bottom. These angle those wires out to the front. All right? And the other one mounts them so they go vertical. All right? So we're going to decide which ones we're going to use. All right, so let's talk about our flight controller. So this is an F3 flight controller. I'll get it up close where you can kind of see it. Different components and different connectors. All right. So one we're going to use the most here is this micro USB connector. So we want to have that off to this, pointed to the side where we can get to it pretty easily. So if we've got to do some configuration when we're in the field, we can get to it pretty easily. Now if you look at this arrow right here in the center, so that arrow points to the front of the aircraft. Right. Now in general you want to build the aircraft where that's pointing to the front. However, in this case, in order to do that, we would have that would put the USB connector in the back. So in the software, you can tell it that this is rotated 90 degrees left, right, and that way we'll reset that in the software. So we're going to build it to where it's going to mount onto the aircraft like this, so we can get to that micro USB port. So it'll be on the side right there where you can get to it. All right, and we'll just tell it in the software that we rotated it. All right. So, now, all these little holes here are for these connectors. So you have 2 sets. One is angled, and the other is straight vertical. All right. So, in this case, we're going to use the vertical ones because we're rotating this to the side. Otherwise, those would stick out. If you're going to build this to where this points to the front and the micro USB in the back, then you can use these connectors that are already angled, solder them all in there like that. All right. So again, not overly difficult to do this, but we're going to build it with these pins going vertical. You can do either way as you choose. So if you see, these pins are going to set in there like that, and you can just see they're sticking out just a little bit here, and so we're going to have to dab each one of those with solder so it connects with these points down here. So not as hard as it sounds. All right, so we'll get started with that. So we just want to set it up like that. Set this down. Let me zoom in a little bit, make it a little bit easier. All right. Set a little. Something like that, just to kind of keep it level. And we're just going to dab a little bit of solder on the top of each of these points. All right. want to make sure you have a good connection. So we just heat it up, we have a little on there, just like that. But we have to do every single one of them. Now, what you don't want to do when you're doing this is you don't want to bridge any of these to the other. One of these is a negative, one is a positive, and one is a signal wire. And if you bridge a positive negative, you'll have a direct short, and you will, once you connect power to it, you'll directly short out the battery. So, even though it's a little bit fine work, it goes pretty quickly. And that should be it. Alright, so we took a little closer look, had a couple of them that were had to do a little adjusting to, but in general it went pretty well. So that's all we have to do with that. Okay, so these are the wires that came with the flight controller. We are really not going to use any of them except for one of these. And this one we're going to solder on to the power distribution board on a 12 volt pad, and it's going to plug into the point over here that says VBAT. So it's a little hard to see. I'll see if I can bring it up and maybe we can get focus or not. But this connector right here has got a little symbol that says VBAT on it, and that's battery voltage. All right, so what this does is this plugs into a 12 volt pad on the power distribution board and plugs into here, and it will tell the flight controller what the battery voltage is. All right, so kind of an important one. So we're going to solder that onto the power distribution board. Now we know that we're going to mount this. So this is the front of the aircraft here. This board is going to mount like this. The micro USB is on this side. So the VBAT connector is actually back over here. So this wire is way longer than we need. We're just going to tap onto the negative and positive right there, or we'll put them right there, and that will give us the voltage requirement that we need. But these wires are a little too long, so we'll cut them back, tin them, and connect them up here, and then they'll plug into that VBAT marker connector right there. Alright, so one thing we're going to do before we go any farther, we're going to check and make sure that we have don't have any short circuits. So we go positive to positive, should give us that right there, and we go positive to negative. Okay, good. So we do not have any short circuits. Alright, important to check before we start thinking about applying power to this. Alright, so we just clip that wire off. Now these are really thin silicone wires, so you don't even need a wire stripper to strip these out. Alright, but the process is the same. We're going to roll them on our fingers. We're going to tin them. Tin them up, make them easier to solder to the power distribution board. All right. All right. So here we're just going to power right on to the 2 leads right here. Positive and negative. So you've got ground. And positive right there. And that's all we need. So next we're going to do is we're going to mount that power distribution board on top of the aircraft. So we took our metal screw out and we're putting our nylon standoffs in. They just thread right on there. Tighten them on. Now what's nice about these is you can add more and more to them and make the stack as high as you want to accommodate whatever components you have. So, alright, so you just want to tighten those down nice and snug. They don't need to be ratchet tight. If you tighten them down too much, you'll just break them. They're nylon. Alright, so this is the front of the aircraft. We're going to mount this like this so that we have this coming off to the side. And from here, we are going to put in a couple of more screws. So we are going to mount a straight nylon screw into 2 of these to hold the board in place. We just need a small Phillips screwdriver. Screw those down. We're just going to mount these 2 for now, because what's going to go on this side is our radio receiver. And the one that came with your kit looks something like this. So those holes are set to mount right there like that. And so what we'll be doing is setting standoffs there and mounting these over here. Alright? But we'll save that for later. Now, if you look at the flight controller, I'm going to get it to where it's in the camera right, you can see that these are numbered 1 through 8. Now this we only run 4 motors on this, so we're going to plug in these into motor number 1 through 4. So we're going to take the connector from motor number 1, and if you looked on here, maybe a little hard to see right there, get it in the screen, you've got a negative, a positive, and a signal. Alright? Negative, positive, signal. So there's no positive wire on these connectors, but there's a negative and a signal. So black is negative and white is the signal. So we plug these in, goes just like that. So motor number 1, this is motor number 2, number 3, and number 4. White wire should be at the top on all of them, just like that. Alright, so that's what it's going to look like. Alright, so those are plugged in. So this is that VBAT wire we soldered onto the bottom of the on the flight power distribution board. So we're going to plug this into the VBAT connector right there. Now, I would recommend that when you do that, put your finger on the top of it. Oh! Sorry, that was Ranger, my assistant. He thought he needed to put a paw in here to help. Put your finger on the top of it so that when you plug it in, it doesn't break the upper, this plastic sleeve. And the pins are on the bottom, so you just slug it in until it snaps in place. And they're all that way. I would just be careful of all of them. Press on the top of them. If you push or pull too hard, you can actually break those off the board, and then you have to replace the board. or can't use that particular position, and some of them are more important than others. Alright, so we skipped a step here. We're going to have to step back for just a second. Take the board loose for just a minute. So the step that we missed is we have to power the camera and the video transmitter off the power distribution board. So we're going to have to solder those wires before we go a whole lot farther. So in the box that the video transmitter came in, you have the video transmitter, and you have the wire harness, and there was an antenna as well. We're not going to use that, so it also, your kit came with one of these cloverleaf antennas, so we're going to use that instead. So the wire harness, you've got a positive and negative, and you have a red, or rather a yellow, black, and white. Now the white is for audio, and if you look at the receiver itself, it shows you right there what the different points are. So you've got ground, audio, video, ground, and 7 to 24 volts input. That's good. So the audio is the one we're not going to use. So what we'll do is we'll just clip that wire off. You can either take it off the connector itself, and I can show you how to do that, or you can just clip it right here at the base. It doesn't matter, we're not going to use it, but you'll want to get it out of the way. One thing you're going to want to do, so this video transmitter uses a slightly older way to change the channels. It's a matter of changing these dip switch settings. So we're going to take a little razor knife, cut into that so you can get to those. So once you peel that tape away, you can see these little dip switches right there. And so to change the frequency, you flip one up or down. Now I believe this is a 32 channel. And on the back of the box, it shows those dip switch settings and where they need to be to set those different frequencies. So you're going to want all those drones on different frequencies. And we're recommending about at least 40 megahertz spread between channels. Otherwise you could get some bleed over. All right? So keep the box. Also, there's some instructions in here. You want to hang on to those so you can know which way to, how to change the frequencies, and then what the bands are. All right, so hang on to that. So this is the wire harness for the flight controller, or for the video transmitter. So you can either cut the wire off here, the audio wire off there, or you can, with the help of a couple little tools, go into the wire harness itself, the connector here, and you can pull that wire out. So I'll show you how to do that. It's pretty straightforward and pretty simple. It takes a little bit of flip that connector up, and it just pulls right out of there. All right, but there's nothing wrong with just clipping it off as well. All right, so positive and negative. We're going to go to positive and negative poles on the power distribution board. These two wires, the black and the yellow, are going to go to the camera to get the signal. And then the camera wire, which looks like this plugs into the back of the camera. We're going to disconnect those from here, cut those off, and the yellow and the black, we're going to solder onto the yellow and the black going to the power transmitter, the video transmitter, and then this red wire is going to go to a positive point on the power distribution board. So let's get going. These are much longer than you need, so we'll cut these back so that we have a little better, cleaner build. So the video transmitter is going to mount back here. So when you put the top plate on this, once it's built, the connector for the battery is going to go through there, and the antenna for the video transmitter is going to go about there. Now, if for some reason it won't fit through there because of the build, it's not a problem, but that is ideally how it is supposed to be built. But because we mounted this power distribution board this way, it might be that it won't fit on there very well. So we'll just have to see how that goes. But for now, we're just worried about the length of the wires. And since we'll just plug this in. Always check the pins, see where the pins are on here. The pins are at the top, holes are at the top there. Slide it in, nice and steady. There you go, snugged in. All right, so now we'll set it about where it's going to sit, which is about there. And then we'll just measure out the wire. So this doesn't need to be longer than probably about that. And we'll just solder them onto these points here. Make them just a little bit longer. Flip them off. Again, silicone wires makes them nice and easy to strip off. We'll just tin those and solder them on. Now these are going to go up to the camera. Again, these are significantly longer than you need. The camera's going to sit up there. So we're going to cut these back to about here, and we'll cut the camera wires back as well. So that's about where those are going to go. Alright, and that is how that's going to be. Strip those off, tin those up, and then we'll be soldering to this. So this is the connector wire for the camera. The camera's going to sit about there. We're going to cut these wires off right about there. At least the black and the yellow, we're going to cut off right about there. They should connect up just fine. And the red wire is going to go to a positive 5 volt. As I mentioned, that 5 volt is right over here. So it's going to go to that point there. We'll make it just slightly longer. And these will strip. Alright. Take our solder and tin these wires up. We'll connect the black and yellows together. Get a little more. And we should just be able to touch these up. It's a little bit long, we're going to cut that back. Don't need quite that much wire for that connection. Alright, so we got those soldered up. Put a little heat shrink on there. Do a little old school. So we'll connect the positive and negative up. I'm going to disconnect this from the VTX. Solder these two to the positive and negatives. All right. All right, there's those two. Two positives are on. And there's the positive and negative. They're on there. Alright. That's going to go through and we'll see if we can lace that underneath to keep it out of the way. Sometimes you can, sometimes you can't. Looks like we're okay here. Alright, so that pulls that up through there. This is my positive. It has to go to the 5 volt. I'm going to connect it right there to my 5 volt line. There we go. It's a little close to the negative, so we're going to reset that. Alright, so we soldered on the 5 volt positive wire to the camera leads. We've got the other ones all connected up. So let's get that flight controller board back on. And it's going to go that way. Let's get our, screw these in here. Just to hold that in place. And again, we'll put the motor wires back on. Motor 1 back here. This is motor 2. Motor 3. And motor 4. We're going to wrap that around, kind of keep that wire out of the way if we can. VBAT plugs back in. There we go. So now what we'll do is we will get some double stick tape and mount the transmitter. Now, one thing important to know about the video transmitter. You never want to power up this aircraft when it's connected. Never power up the transmitter without an antenna on it. The antenna creates a load. Without it, the transmitter will burn up. Without a load on it, it'll just override and it will burn itself up. So, always want to have an antenna connected before you connect power to the aircraft. Alright, so we're going to put a double stick tape on there to hold it in place while we get the other equipment ready to go. Alright, so we put a little double stick tape on there, peel the other side off, and set this in place. Now once we get ready to really start flying, we'll put a zip tie across that to make sure that holds and stays in place. You got a couple little slots there that a zip tie will sit right through. So we're going to set that right there like that for now. And that comes up here and goes to the camera. So we are going to take the camera and we are going to plug it in. and in a bit we will power the whole thing up and confirm that we have power and that we're getting video transmission. Alright, so we're going to talk about the camera mounting real quick. So the camera's going to mount between these plates here, and then these plates slide into slots on the upper and lower sections of the frame. So I just slide into the slots and the camera's mounted between there. This is in the front and also helps hold the camera in place. Now this is mounted with these small little screws that came with it through the holes on either side of these plates. So we're going to mount that right now and get that ready to go. Now as you can see, we've got a couple different options for holes there depending on where you want to mount it. We're going to mount it in the center. As you fly, you may want to put it in different places, and that's entirely up to you. But what we're going to do for today is just mount it in those center holes. They're very fine little screws. You can use a small screwdriver to hold them. And this is a plastic frame, so careful that you don't over tighten them. I'm going to use one of my little jeweler screwdrivers here. And we're going to set that in place. Like I said, these are a little bit fine. Screwing them in may be a little bit of a challenge. As you can see, it is for me. There you go. There's one. We'll set the second one in place. If you really get into racing, you may want to change to different cameras, different transmitters, different flight controllers. So this is an F3 board. They make a slightly newer version, an F4 board. And I hear they're coming out with an F7 board. I don't know what happened to 5 and 6. There we go. So that is what the camera is going to look like mounted there. So you can see the camera's got a little marking that says where the top of the camera is. Always helpful. We're going to plug those wires in there. And then there's little slots where the frame sets, these pieces set into the frame. And there they are. All right. So that's how that's going to go on there. We're going to pull that off for the time being because we've got a couple other things to do. All right. All right, the last bit of soldering that we have to do is to get power up to the flight controller. And it doesn't come through the VBAT wire. It has to come and plug into one of these open ports over here. All right. So what we're going to do is take one of the wires that came with the flight controller. You actually got two of these. And we're going to take the one that has a white, red, and black wire. All right. We're just going to clip that off of there, and we're going to use that to get power up to the flight controller. So we're just going to clip it off. And that's what we're going to use. Now, we don't need the white wire. So just like we did on the other connector, we're going to pop up that little piece right there. And we are going to remove it from the wire harness because there's no signal wire necessary. So we're just going to use a little screwdriver. We're going to, best we can, pop that up. that'll just slide out, and that's all we need. So again, silicone wires, just use our fingers, splice them back a little bit. Tin these wires and connect them to the 5-volt. So the flight controller, as I mentioned, the camera, and the LEDs are all 5-volt. So you don't want to put 12 volts into this flight controller. It won't like it. So let me get my pliers with a scrunchie. Hold those up. Tin these wires real quickly, and we will attach them to the 5-volt points. There it is. Now these are a little long, so I'm going to clip that off just a little bit. In these situations, when those wires get a little long, you run the risk that they'll short out or connect to a bridge over to a point you don't want to connect it to. So the 5 volts is right up here in the front. Let's pull this out of the way. You gotta be a little careful doing it like this. You might want to do it before you connect all these wires up. That's the way I should have done it, but you just don't want to short anything out or melt any wires. So we'll put this one we're going to disconnect that one there to get it out of our way. I'm going to take this around a little bit and get us 5 volts right there. And our negative is going to be right next door. Alright, so I'm going to take a good look and make sure we didn't bridge. It's a little close, so we're going to see if we can fix that, because what we don't want that looks better. Let's take a magnifying glass real quick. I'll touch it up one more time. We just don't want something shorting out, and that's what we run the risk of if we're not. Oh, and that definitely bridged the wrong way that time. Okay, I think we're okay now. Just takes a little practice. As long as you have power going to it, you can have those kind of mistakes. And that looks okay. Give the wires a little tug, make sure everybody's on there tight. Looks like they are. So that's going to do it. So now we'll plug our motor wire back in. There we go. Like that, set our nylon screws back in place. Like I said before, you don't want to really wrench those nylon screws down too tight, they're just going to snap. If you get in a severe crash, they can crack as well. Again, that's not the end of the world. So there it is. So now we have power for the camera, power for the flight controller. So what we're going to do, if you recall in the flight controller, the negative wires at the bottom, positives in the center, and signals at the top. We are just going to plug that into the port right there at the end, number 8, and all we're doing is we're providing power to the flight controller via this wire right here. and again 5 volts. All right, there we go. That is all the soldering we should have to do for this build. All those pieces, so not too bad. So now let's connect up our camera. There it is, set in place. This particular camera, we're not going to be able to use that front mounting piece. Alright, hold that down. And then let's put the top bracket on. There we go. So you see those are sitting flush right there. So we are going to, at this point, put on one of our holes. So these are where the smaller, shorter screws are used. Alright. Just going to flip and hold this over and set one underneath. And that should keep the frame somewhat together. Let's put the rest of the pieces in. Really more worried about this front popping off. Alright, so that is roughly what it's going to look like when it's complete. Alright, and so we just go ahead and put the rest of them in place. Alright, so we got that all lined up. I took the top plate off because we've got to configure or set up the radio receiver. So this receiver is what came with your kit. Right? This is what it looks like. So we are going to, it's got those holes in there, and they're going to line up, and we're going to mount it right there on top of that. And these wires are going to go to the front and to the back, and there are your radio receiver wires. They pick up the signal from your remote control. So that's where those are going to be. So, having built one of these before, I think these holes are actually a little too small for the screws to go through. So we're going to take a driver, drill, and we're going to make those just slightly bigger. So let me do that. So what I found with these is I got to take a drill and just make them slightly bigger. There we go. So now they'll line up. So the connectors that come with this kit, with this receiver rather, are these. Now, this big octopus of a wire we are not going to use, but we are going to use 2 of these. And what we have to do here is we have to cut these and splice inside of them together. Right? So one's going to plug into the I/O port, and the other is going to plug into the PPM connector. So if you look close, maybe a little hard to see it on the video, but this connector is labeled PPM on that side, and this one's something that I cannot read. But the port on the right, the PPM, that's the one we're going to use. All right? So what will happen is one of these is going to plug into the PPM port, and then one of these are going to plug into the I/O port 1 on the flight controller. So, even though this is extra long, this fits in just fine on that side. All right? And that's where it's going to go. All right. So first, let's cut and splice these wires together. Again, friendly silicone wires, just use your fingernails to strip them back. And these are the same, yellow to yellow, red to red, black to black. Alright. So we'll tin these guys up. That's one set. I'll use my Alright, so there's several different protocols for getting a flight controller to talk to the radio. There's PWM, which is an older version. There's PPM, there's CPPM, there's S-Bus, I-Bus. There's several different ones. Plus there's different protocols for remote controls. And it doesn't really make a lot of difference. They will all work with this. It's just a matter of getting the right combination and having the right settings in place. So, these are a little bit long. We're going to cut these back. And you might hear my associate Ranger in the background. who is always anxious to help when it comes to drones and aero robotics, even though he doesn't really understand because he's just a cat. And there it is. Now we'll just connect it into the right ports. So again, on here it's going to connect into the PPM port. Pins are up. There. And here it's going to plug into the IO1 port. Alright, so the port that this goes into is the IO1 port. And the IO1 port is over here next to the VBAT connector. And we'll check this, and the pins are up, so it's going to go this direction. On this side. Alright, so as you can see, it plugs in to the back end here of IO port 1. Make sure it's snugged all the way to the back. Same side where the VBAT is, it just plugs in to the opposite end. Then we're going to mount this and get ready to go. Alright, we'll just set these standoffs in here. And then the last two screws to hold it in place. That one, and then this last one. All right. All right. Now we're going to do a couple more things before we put the top back on. We've got to bind this receiver to the transmitter. Alright, we'll just set these standoffs in here. And then the last two screws to hold it in place. That one, and then this last one. All right. All right. going to do a couple more things before we put the top back on. We've got to bind this receiver to the transmitter. Alright, this part's a little tricky. We've tried it a couple of times now. I think maybe we got a system for it. So, here's our transmitter. We'll leave it powered off. So the trick is, you have to hold down this little bind button, which is that button right there, while you power it up. And when you do, the LED light on it will start to flash a fast red flash. So we're going to see if we can do it. Probably going to take two people when you're trying to do it, but we're going to see if we can pull it off. Alright, see we got the fast flashing LED. That's what it'll look like. And so then what you do is you hold the bind button down on the transmitter and power it up. And it just showed it was binding, and it goes to this screen. So now you can see you're getting a receiver signal here. And so you know you're bound. Also, the LED light on the drone, on the receiver, you can see it's solid red. So that's how you know you're bound. Alright? So it's that simple. And once it's bound, it's always bound. So it'll always pick up this radio, this aircraft, and this aircraft only. You can have 8, 10 of these flying at the same time. Each one is bound to a separate transmitter, so you don't run into a problem. Right, so that's how that's done. So let's put the top back on this. I'm going to power that down, turn the transmitter off. Now it gets a little tricky doing this. You've got these carbon fiber plates to line up. So this takes a little bit of maneuvering. So you've got to line them up on the bottom plates here. And that's set in there on this side anyway. We'll put the plate on and we'll at least get a couple of screws in. Like I said, it takes a little bit of maneuvering. Once you get the first screw set, it's pretty straightforward. So that one's set in place now. We'll set a screw on the front end here. Yeah, we're going to try to get one set on the front end. Try that one. Alright, so that's one is set. So now we'll just align it all. Now they kind of drop into place, and now it's a bit easier to get the rest of them to align. Set this one in the front. Give me a little bit of trouble. Alright, so I'm going to just go through and reset and then screw all those down. So. Alright, so we're going to start a configuration. So what you're going to need is a micro USB cable. One plugs into your laptop and one will plug into the drone. And that little slot that we've talked so much about. Alright, it's going to sit there. We're not going to plug that in just yet, so we need to get a couple of pieces of software. So the first one we're going to need to get, and I use Google Chrome, and so you just go to the Google Chrome store, go to the apps, and you can search for a program called Betaflight, B-E-T-A-F-L-I-G-H-T. Okay, and there it is. You just click here, add it to Chrome, and we're going to add the extension. Alright, So it has been added. So the other one we're going to need is called Bell Heli, or BH Heli. Alright, so probably the best way to find it, just go into your search engine, put BL Heli Configurator. There's the extension. And if you don't already have it, which I do, you tell it to download the application. Now we'll use that to reverse the motor thrust, reverse the motor direction if we need to in this configuration. So we're going to save that for later. So we got our apps. There's Betaflight. We just click it and turn it on. All right. Now I've had a lot of good success with Macs to do this. Windows can sometimes be a bit of a challenge. So when we plug this in, it should automatically connect. Well, let's see. So it changed our setting up here, and we hit connect, and there we're connected. So here's a representation of the aircraft. So as we pick the aircraft and move it around, you can see it's reading those sensors in there, the accelerometers, the compass, and all those pieces. So you've got a connection there. You can see up here it shows red and disconnect. So to disconnect, that's what you do. So the first thing we're going to do is we are going to do a calibrate the accelerometers. So we're going to hit calibrate, set it on a stable table, don't do anything, let it go through its calibration. It's already done that. So that's done. And we're going to go to ports. We're going to set the UART2 to serial RX, which I'll just save and reboot. All right? It's rebooting, now it's ready. So here's the configuration page. So we're flying in a quad X configuration. You can see the motors are 1, 2, 3, and 4. Not sure why they do it that way, but they do. We're going to come over here, and if it doesn't already select it to motor stop, we want to set it to motor stop. Okay. We'll scroll down through here. Accelerometers, barometer if it's supported, magnetometer if it's supported. Okay, here we want ppm RX. That's what it's set for. So we'll leave it there. We don't have GPS, so we're not going to play with that. We do want to turn the OSD on-screen display. We're going to disable some of these alerts. And we're going to tell it to save and reboot. And if you look up here at the top, it says device ready. Just before that, it said rebooting. Alright, so we don't have a battery connected up to this, so we're going to do that right now. And there's some additional settings we're going to take care of when we do that. Alright. Turn our transmitter on. Scroll through here again. So those are all tones and beepers that'll go off. The battery's critical low when it's low. So we'll leave those in place. Tell it to save and reboot. There you go. And we're going to go to power settings. Alright, so here we can set minimum and maximum voltage, cell voltages. We're going to leave those as defaults. Those look pretty good to me. 3.3 is a minimum cell voltage, 4.3 is a maximum cell voltage, 3.5 it gives us our cell voltage warning. Alright, so we're going to save those settings. And if you look up here in this upper right corner, it shows right there it's connected, it's a 3 cell, This battery's got 11.5 volts in it, and it's showing the amperage and the milliamp hours, so that's good. Now, PIDs tuning, we're not going to play with those. We're going to leave them as the defaults for now. So as you see, as I move the remote control, that is making that corresponding move on the aircraft, on the screen. All right, so we're going to go to the receiver. Now, what's good about this is it automatically kind of knows what we're doing. So our channel map right here, we've got it set to AETR. That's ailerons, elevators, throttle, and rudder. 1, 2, 3, 4. All right, that's set. So if you look on the roll, which is the right stick, moving it left and right, you can see that it is moving that top indicator. It says roll. Pitch, again, moves it just fine. Yaw is the stick on the left, makes it rotate. That's working fine. And then throttle is up and down. All right. Now we've got a couple of auxiliary channels, auxiliary 1 and auxiliary 2. We're using switch A, auxiliary 1, and we're using B for auxiliary 2. And it already knows they're there. There we go. And we're going to tell that to save. Hit the save button on the bottom. All right, and that's done. Modes. Now I've set these, so this is where we set the arm. So you want to add the range. Click on add the range. Okay, it's set on auxiliary 1, and right now that's where that's set. So right now it is disarmed, and when I flip this down, it moves that indicator over here into the arm section. Now you can take this and you can slide it the other direction if you want to have the switch polarity reverse to where when it's armed the switch is up. You can do that. All right, but for what we're going to do, set it that way. When we flip the switch down, that means it's armed. When it's armed, that means that the drone is ready to fly. All right, and that is, we're using this switch right here, switch A. All right, let's back. And then we're going to set the second one as horizon. So this has to do with the flight modes you can fly it in, and we're going to use that. And so that is set to switch C, as you can see, moving it that direction. All right, I'm going to tell that to save. Now when you get into here, these will probably be turned off. So what you just have to do is just put add range, and then you set the switch. All right, I'm going to take that out of there. All right, tell it to save. Now we're going to go to the motors. Now this is where we determine whether the motors are spinning in the right direction or not. Now this obviously is not going to work if you don't have a battery connected to it. So what you have to do here is you come down here and you have to say you understand the risk. So make sure you don't have propellers on. Make sure you've got wires aren't going to rub against the motor, the outrunner motors. You click that, I understand that. We're going to switch on main battery voltage. We're going to switch on an artificial horizon. I'm going to switch on a timer. Tell it what flight mode. We're going to tell it that we can name the aircraft. And you have several others you can put on there. Warnings, average cell batteries. You've got a lot of different things you can put onto that screen. However, you cloud it up too much, it makes it a little too hard to see. So we're putting the name down there. Set that one in that corner, and you can just drag these wherever you need them. Now our recommendation is put them where they're a little out of your field of view, because as you race, you want that information, but you don't necessarily want it right in front of you. All right? And then you have warnings, post-flight stats, and other things you can select on there. So we're going to tell that to save that. and that is saved. All right. Black box, we're not going to play with that as a way for it to record kind of what happened on the last flight. We're not going to do that. All right. All right, we're going to go back to setup. Now, what we did, if you recall, when we installed the flight controller on this, is that we rotated it so that we could have better access to that micro USB port. All right. So the arrow on this aircraft is actually pointing to the side. So we have to tell the software that we have rotated the flight controller. Alright, so we had one minor error. We went to do a test on it. It wouldn't fly right. So we got to make one. We made one change. So these are for external. If you have external gyros, accelerometers, or magnetometers, the board sensor, we had to change this. So we rotated that 90 degrees. So we had to plug in there a 90-degree yaw. So then just save and reboot, and you're done. So here we have board and sensor alignment. All right. So the setup on Betaflight is done, with the exception we have to go in and reverse 2 of the motors. And we use a different app for that. All right. So the app we use for that one is called Bell Heli Configurator. All right. All right. So we're going to open up Bell Heli Configurator. There's a drop-down menu here. You may have to select a different port as you get this to connect. I've had really good luck with Mac, Apple, or rather IBM's can from time to time be a little bit of a challenge. All right, so we're set up there. We're connected, as you can see, and we're going to tell it to read the setup. All right, so it has read the setup, and this is where it says it is set up. All right, we're going to do that. Now we have to reverse the motors for motor number 2 and motor number 4. So here's ESC number 2. It's to normal. We are going to go to reversed. Okay. We're also going to have to do the same on number 4. Reversed. All right. Now here down at the bottom right it says write setup. So we're going to write that data to the ESCs. And that should be it. So what we'll do next, we'll go back to Betaflight. We'll open that up and we will test the motors and make sure they're spinning in the correct direction. So we'll close this out. I'm going to disconnect. I'm going to close it out. Open Betaflight back up. Connect to Betaflight. Down here to motors. Going to hit that switch. And so number 2 should be spinning counterclockwise. And it is. And number 4 should be spinning clockwise. And it is. Alright, so it all worked fine. Alright, so that is all there is to it. It always sounds easier than it is. We're going to enable expert mode for a second. And we're going to come in here, and there's a setting on the left that says failsafe. When you enable expert mode, you can go in here to failsafe. And what we want to make sure we've got it set is that in failsafe procedures, it just drops. So if something goes wrong, it goes into failsafe, it's just going to come down. And that is all we need. Tell it to save and reboot. Okay, there you go. So we are done with Betaflight. We're going to close that out. We're going to disconnect that from the computer. So when you turn your transmitter on, if you have any switches that aren't all the way up, it gives you that warning. Also, if the throttle's up when you power it up, I'll show you what that looks like. So the same thing. It gives you a warning that tells you that you've got the throttle up. Okay? So it won't completely boot up if the throttle's up. That way if it's connected and the aircraft is armed, it'll start immediately spinning. So to arm the aircraft, arm the motors, we flip the switch down. So now it's down, it should be armed, so when I increase the throttle, the motor should start to spin. And there they go. Alright, so that's set up. So we're going to put some propellers on it, we're going to take it out and take it for a little spin and make sure it all works. Okay, so we put the Velcro strap on that's going to hold the battery in place. And we're going to put the propellers on now. So you should have 2 sets of black and 2 sets of green. So in each bag is one clockwise rotating blade and one counterclockwise rotating blade. What's good about this is the motors are marked which direction they're spinning, so it should be easy to connect these up. Might as well point this out. If you leave the transmitter on for an extended period of time, it will start to make a little noise, reminding you that it's turned on so you don't run the batteries down. So if you want to keep it on, you just flip one of the controls or move a switch and it resets that timer. But since we're not using it, we're just going to shut it off for now. Now, my recommendation is you put blades on the front that are one color and blades on the back that are a different color. So these 2 green blades, if you look at them, and if you look at the blades, probably can't see through the camera, but there's numbers written right here, right? So that's the top of the blade, right? So don't put it on this way. It'll go on that way, it just won't fly, right? So where you have the number on top, that's where that goes. Now this blade, you can see that as it turns, it's going to grab the air, push, lift, get to lift that direction. So this blade spins clockwise. So it goes on the clockwise rotating arm, which in this case is right there. This one would be the counter rotating blade. It's going to go on that arm. Okay, so I've got 2 black blades. Again, the numbers are written here on the top. Maybe a little too hard for you to see, but this is a clockwise rotating blade. It's going to go over here, and the counterclockwise rotating blade is going to go on this end over here. So, in your kit, you got a very handy little wrench used to tighten those. Let's go on there. Now when you tighten these on, so these nuts have a little plastic sleeve, you can kind of see right there, and that is to help it keep tight on the motor shaft. All right. So as you take these off, keep in mind that if a counter-rotating blade is going to have the nut is going to be threaded the opposite direction. All right? So this blade spins this direction. We'll put it on there. And this has got left-handed threads, so just keep that in mind as you're putting it on there. You want to put them on good and snug, but if you over tighten them, you run the risk of cracking that propeller at the root there. All right. And this is a counterclockwise. I just want to put it on. There you go. Now these are 2-bladed propellers. Some racing drones will have 3-bladed propellers. Some you can get 4-bladed propellers. So the propellers, the more surface area on the propeller, the more drag it creates, and the more power the motor has to have to drive it. So the more power the motor has to have to drive it, the more power you have to have is flowing through all these systems. So keep in mind that this is these blades are all just fine. If you want to go to 3-bladed propellers, you can do that. Just know that if you're going to do that, you might need to go from a 3-cell to a 4-cell battery to have enough power to really drive this. As you get better and better, you'll want to go faster and faster. And as you go faster and faster, it takes more power. So you'll want to tweak these things as you go along. All right, so we're going to take these wires here and we're going to tuck them in, make sure they're out of the way, because the last thing you want is for that propeller to catch that wire and cut it, because it will, it can, and it will. And when it does that, you'll lose that motor, and when that happens, it's going to spin out of control. So we're going to take a little zip tie here, and we're just going to pull these wires in, and we're going to zip tie them down. And your kit comes with a few zip ties. And really all we're doing with that is just keeping those wires from getting in the way. Alright, so last we're going to talk about is Velcro. So you'll want to put a piece of Velcro on the battery. And what I tend to do is put Velcro on one side, that is the furry side, and then the hook side on the other. That way, whichever way I mount it, I've got one or the other available. So your kits came with little sets of Velcro. Since the pile side on mine is the longest, I'm going to put that down on here. The Velcro helps hold the battery, keep it from shifting around in flight. Alright, so you got two things that help hold that battery in place. One is the Velcro strap, and the other is the Velcro pad. Now we're going to tuck that through there, through that. Again, so these little wires here are the balancing cable. You'll want to make sure that you've got those secured as well, and the Velcro strap is the best way to do that. So it'll keep that out of the way. Zip it down. And when we have it ready to go, that's about what it looks like. Now this battery is significantly larger than you're going to want to fly with. This is a 2200 3-cell. Normally you'll fly with about a 13 to 1600 milliamp hour 3-cell or 4-cell. This is the battery I happen to have right now available, so that's what we're going to use. So we are going to take it outside and get a little spin and see how it does. Okay, so the remote control, the way it works, so to fly the aircraft, you flip the switch down and it arms it. Once it's armed, when you get increased throttle, it comes off the ground. All right, that just makes the motor spin up. All right, so the more you push this up, the higher it's going to go, and or as you're flying, the faster it will go. All right, this makes it yaw left or right. This makes it fly away from you, towards you, to the right or to the left. All right. This switch here is your function mode, flight modes, so it's at its angle or horizon. Those are what they're set. There are other flight modes you can set if you wish. Those are the basics. If you take it off and it crashes, or you set it back down, or the motor